chapter 3. In chapter 2, we use the frequency distribution to help us organize the data, to find out the general pattern of the data and the shape of the data. And we also find out where the values tend to concentrate. And in this chapter, we're going to continue the same goal to describe the data, to find out the center of the data and where the data tend to concentrate, but using different method. In this chapter, we're going to use mathematical method. In addition, we also want to find out if the center of the data we found are typical or representative. So that means we also need to find out how the data spread out around the center of the data. If the data widely spread out, and then that means the center of the data we found is not typical, cannot be representative. If the data is clustered close to the center of the data, and then the center of the data are typical or representative, we're going to use the standard deviation to measure that. Therefore, we're going to cover two main parts. One is the measures of the central tendency, and the other one is the measures of the variability, or we say dispersions. Let's take a closer look at this. And we usually calculate the mean, median, or mode, and a weighted mean to measure the central tendency. And the central tendency is a single value used to describe the center point of the data set. We try to use this single value to represent the whole group of data. First, mean number, or it's an average value, is the most common measure of the central tendency, and we calculate the mean by adding all the values in the data and then dividing the result by the number of the observation. Here is a formula for the mean. Okay, one important thing is keep in your mind that the symbols we used to represent the mean, okay, and to represent the elements in this formula, and there are different formulas for sample mean and for population mean. So the formula for the sample mean is x bar equal to the sum of all the values then divided by the number of the observations in the sample. X bar again represent the sample mean, and x sub I is the values in the sample, so x1 or x2, x3, x4, until xn. And this is sigma. Sigma means the operation of the summing up, means the operation. So sigma I equal to 1 to n xi is the sum of all the values in the data, and n is the number of the data values in the sample. So here x bar equal to x1 plus x2 plus x3 plus x4 and plus until the last one, the last observed values xn, then divided by sample size n. The formula for the population mean is mu. Remember, we use x bar for sample mean, and mu means population mean. Okay, mu represent the population mean. Mu equal to the same thing. We sum up all the values in the population, then divided by the number of the data in the population. And here we use a capital N represent the number of the values in the population. Again, please keep the x bar and the mu in your mind, that they represent the sample mean and the population mean respectively, and you're gonna see them a lot in this class. And when you say mu, you need to know what that represent. It represent population mean. Examples. Suppose a sample of size n is 5 given the following values. So the question already, told you it's a sample. Then sample mean is x bar equal to, we sum up all the values in the sample, then divided by number of the sample 5. So we get 30.4 divided by 5 is 6.08. Next, weighted mean. Weighted mean allows you to give the different values different weights. So more weights for more important values and less weight to others. So this is the formula for the weighted mean. Remember, weighted mean is also x bar. Okay, so x bar equal to the sum of the product of the weight and the each value in the data set, and divided by the sum of the weights. Examples. Here example of the dates that you worked for each week and the frequencies. So it means there are 4 weeks that you worked for 3 days per week, and there are 7 weeks that you worked for 4 days for those 7 weeks, and there's 6 weeks you worked for 5 days. So here we can look at these frequencies as weights. So to find the average number of days worked per week, you need to calculate the weighted mean. So weight times the value, okay, 4 times 3 plus 7 is the weight. So weight times the value of 4, then plus 6 times 5 plus 3 times 6, then divided by the sum of all weights. Remember, we use the frequency as the weights. Then we get a 4.4. So the average days, number of the days you worked per week is 4.4 days. Okay, so mean is the most common method we use to measure the center of the data, but there are some disadvantages with the mean. So one of the disadvantages is the mean number is easily get distracted or distorted by the outliers, means by the extremely large number or extremely small number. So if there is only one very extremely small number, and then it will bring down your mean number. So that number cannot be used to represent the whole data because there is a bias. Okay, that is why sometimes we use median. So median is the value in the data set for which half observations are higher and half observations are lower. It's in the middle of the data set. So how do we find out the median? Usually we carry out the 2 steps. First, we rank them. We rearrange the data in ascending order or descending order. And then the median is the middle one of the data set. We can also use the index point to determine the position of the median in the data set after we arrange the data in the ascending order. So formula for the index point for the median is I equal to 0.5 times n is the number of the data. Okay, so whenever the index point is not a whole number, round the value up to the next highest whole number. Okay, for example, we are given a group of the data, 7 numbers here, and we first rank them, arrange them in the ascending order, and then we find out the index number is 0.5 times number of the value, that is 7, then we get 3.5. So we round the number up to the next highest whole number, it's 4. Then the median can be found is the number 4th value in this group of data. 1, 2, 3, 4. Okay, then 28 is the median of this group of data. Okay, say you can tell from here that median is not sensitive to the outliers. Okay, if we have 7 numbers 21, 27, 27, 28, 34, 45, and 5000, if we calculate the mean of this group of data, because of this 5000, we're gonna get a huge mean number, because this 5000 bring the mean up, where use median, and median will not be affected by the 5000. It's the center of, it's middle of this group of data, and very obviously you can tell 28 is much more representative of the whole group of data than some number, close to 5000. When there are odd number of the data values, the median is always the middle value in the data set. When there are an even number of the data values, the median is always the mean value of the middle two values. For example, there are 6 data here, then the median gonna be the average of the middle two values. So it is 170 plus 182 divided by 2. The mean number of these two is 176. Mode, the third one. Mode is the value that appears most often in a data set. So the mode is particularly useful way to describe the categorical data. For example, the group data, the frequency distribution, and showing in the histogram, and the mode gonna be the one with the highest bar. Or in the frequency distribution, mode gonna be the one with the largest frequencies, as you can tell here, right? This one is the mode that happen most, and the other one is mode. That means the number of the children of 2, the frequency of that is 8. So mode showing the center of the data, where the data concentrate. To understand more about the relationship between the mean, median, and mode, let's check this graph. Okay, distribution shape. So this distribution shape, showed by the histogram, we call that symmetric. So the whole distribution can be divided into the 2, equal half part, and exactly same. We call that symmetric. And these two are skewed distribution. Okay, the other one is left skewed. One is lean to the right, we call that left skewed, and the other one is right skewed, when the most data lean to the left. Okay. And for the symmetric distribution, mean equal to median in the middle. And for the left skewed distribution, mean less than median. Okay, mean is less than median, because the mean numbers is affected by the smallest value. And for the right skewed distribution, the median is less than mean, because mean affected by a few large values.